Have you ever wondered what's really happening behind the scenes when your favorite app doesn't crash during the Super Bowl or a huge product launch? Well, today we're diving into the invisible force that makes it all work. It's called synchronized cloud elasticity. And trust me, it's this incredible high-stakes balancing act that keeps the internet from falling apart. Let's get into it.
So, let me ask you a kind of weird question. What do cloud servers and a global pizza chain have in common? It sounds like the start of a bad joke, I know, but the answer is actually the key to understanding one of the biggest challenges in all of modern tech. They both have to deal with these sudden, massive, and totally unpredictable surges in demand from everywhere all at once.
To really wrap our heads around this, let's use an analogy. Forget about data centers and servers for a minute. We're going to talk about something way more fun, a global pizza party. Okay, so picture this. A video of your amazing, one-of-a-kind pizza just goes viral. I mean, a billion views overnight. All of a sudden, literally everyone in New York, London, and Tokyo wants one. Right now. And all of your kitchens, which are used to just handling their own local business, get hit with this absolute tidal wave of orders at the exact same time. And here's where the problem really starts. If every single kitchen is its own boss, how do you coordinate everything? How do you make sure they all have enough dough, enough cheese, enough everything? If they don't talk to each other, you just get chaos, right? Some kitchens run out of ingredients in 10 minutes, while others are overstocked. The real question is, how do you get them to act like a team? All right, now let's bring this back to the real world. Just replace pizza kitchens with cloud providers. Think Amazon Web Services, Microsoft Azure, Google Cloud. You'll see, the problem is exactly the same, but the stakes are, well, infinitely higher. The dream for any big company is to have all their services spread across these different clouds, working together like one single brilliant machine. But the reality? It's not like that. These clouds are basically their own separate kingdoms. They have their own rules, their own languages. They just don't naturally talk to each other at all. And that brings us right to our big idea for today. Synchronized elasticity. This is the ultimate goal. It's the fancy technical term for teaching all those independent clouds, our pizza kitchens, to, well, dance together. It means they can all spin up more resources in a coordinated way when demand spikes, and then, just as important, scale back down when things quiet down. So how on earth do you actually do this? Well, the cloud architects, they're like the conductors of this whole symphony. They don't use magic. It all comes down to a few really, really clever tools and patterns that they use to make it all happen. So tool number one is called predictive scaling, and this is a game changer. Instead of just reacting to a traffic surge when it's already happening, this is about looking into the future. It's about being proactive, not reactive. So how does it work? Well, the system looks at all the past data, traffic from Black Friday, past holidays, big sales, and it uses machine learning to predict the next big surge. Then it automatically pre-warms the systems before anyone even hits the website. It's literally the technical version of knowing the Super Bowl is this weekend and telling all your pizza kitchens to hire extra delivery drivers and stock up on pepperoni on Saturday. Okay, the second smart tool is all about using custom metrics. See, for a long, long time, the only way we knew how to scale systems was by looking at really generic stuff, like how busy a server's CPU was. But that's a really blunt tool. It's kind of like deciding to make more pizzas only when the oven is already on fire. A way smarter approach is to use custom metrics that are tied to the actual business. For example, the number of people adding an item to their shopping cart. That is a way better signal of an incoming rush than CPU load. Or you could track social media mentions. It's the difference between waiting for the phone to ring and watching Twitter explode with thousands of people tweeting about pizza night. But what happens when this coordination fails? What if all your systems react at once, but they do it without any intelligence? Well, that's when you run into one of the most terrifying problems in all of cloud computing, the thundering herd. This quote from a senior cloud architect just says it all perfectly. The goal isn't just to handle traffic. It's to avoid having your solution become the new problem. Because in your rush to spin up thousands of servers to fix one problem, you can accidentally create a much, much worse one. So the thundering herd is what happens when all those brand new servers you just created wake up at the exact same millisecond and all scream for the same single resource, like a database or a login service. It's like 1,000 people trying to cram through one tiny doorway at the same time. The door gets jammed, and guess what? Nobody gets through. And the result of that jam is a cascading failure that one database gets overwhelmed and it crashes. Then the services that needed that database, they crash. Then the services that needed them crash. It's a domino effect that can take down your entire platform, and it was started by your own attempt to save it. And the really scary part? The time between that trigger and a complete system meltdown can be 0 milliseconds. The moment those uncoordinated servers wake up, the stampede begins. There's no time to react. The only way to win is to design your system smartly from the very beginning to avoid the herd in the first place.
So, as we start to wrap this up, it becomes really clear that this whole synchronization thing isn't just some technical detail. It's the unseen choreography, the invisible symphony that allows the entire modern web to feel so fast and so resilient. And that really gets to the core of what great cloud architecture is all about today. It's not about brute force, just throwing more servers at a problem. It's about intelligence, prediction, and coordination. It's about conducting that symphony. So let's just recap the key takeaways here. The big problem: clouds are super powerful, but they're isolated. They're islands. The smart tools to fix that: predictive scaling and custom metrics. And the ultimate goal: create a coordinated symphony, not a chaotic, destructive stampede. And that leaves us with one last big thought. This technology is honestly pretty profound. I mean, if we can teach these massive, global, distributed systems to work together in perfect harmony just to deliver a pizza when we want it, what's the next huge challenge that they can solve? Something to think about.